Assalamu alaikum and hello everyone. This is Mehraj Kamran and today we are going to solve AKUEB examination past paper for the year 2021 and this is for HSSC part 1 means first year chemistry paper. So let's start. This was MCQ based paper only. Question number 1 is if a molecular mass of an organic compound is 60 AMU and its empirical formula is CH2O, then its molecular formula will be. To find out molecular formula, we need to find the value of N because we have formula, molecular formula is equals to empirical formula multiply by N. If we will multiply this given empirical formula with the whole number n, we will get a molecular formula. To find out n, we have another formula. N is equals to molar mass. This molar mass will be given in the question always, divided by empirical formula mass. Empirical formula mass you need to calculate from empirical formula. So here in the question you can see empirical formula and empirical molecular formula mass is given, that is 60 AMU. You need to calculate this empirical formula mass CH2O. So 12 plus 2 plus oxygen 16, it is 30. So we will put 60 here divided by 30. From this we will get value of N as 2. Just multiply these numbers with 2. So C1 will become C2, H2 will become H4 and O1 will become O2. So option C is the correct answer, therefore C2H4O2. Question number 2 is the number of bromide ions in 3.5 moles of MgBr2 is. Now moles of magnesium bromide are given and they are asking you the number of bromide ions. First of all, from moles you will calculate number of molecules of magnesium bromide by using simple number of molecule formula. Moles multiply by Avogadro's number. This formula will give you number of particles. In case of compounds, number of molecules will be obtained. So 3.5 moles are given, multiply it with 6.02 exponent 23. So you got the answer. Now if you do not want to type exponent 23, you can just use the number 6.02. With the answer you will write as it is exponent 23. So the answer is number of molecules of magnesium bromides are 21.07 exponent 23, or you can write 2.107 exponent 24. From 21 point I have written 2.1. So this will become exponent 24. From 23 it will become exponent 24. Now these are number of molecules of magnesium bromide. From the formula you can see one magnesium bromide will give you 2 ions of bromide. So if you are having this much molecules of magnesium bromide, how many ions you will get? Just multiply this number with 2. So you got the answer 42.14 exponent 23 or 4.214 exponent 23, that is option C. Question number 3, which of the following does not signify quantitative analysis? And options are option A, predicting the expected amount of a product, option B, calculating the actual yield of any reactant, option C, determining the presence of lead in paint. This is the correct answer. It is not included in quantitative analysis because we are identifying the presence of lead, means it is related to qualitative analysis, not quantitative analysis. In remaining all 3 options we are measuring the quantity of any substance. Like here it is written amount of product, yield of the reaction, nutrients level in blood, all these are representing quantity of any substance. But here in option C it is representing quality of any substance. Now question number 4, if x gram of carbon and 2x gram of magnesium contains the same number of atoms, that is 6.02 exponent 23, then the value of x is. This value is Avogadro's number. Whenever you have number of moles and mass equal, then you will get number of atoms as equals to Avogadro's number. Means this is x gram of carbon, it should be 12 because molar mass of carbon is 12, and here it is written if x is 12, 2x will become 24, and 24 is the molar mass of magnesium, means the value of x is 12. Therefore Avogadro's number is the number of atoms. In answer you are getting the same value. Question number 5, how many grams of nitrogen are approximately present in 100 gram of ammonium sulfate? Ammonium sulfate formula is given and you need to find grams of nitrogen present in it. So from this formula you need to calculate molar mass of nitrogen present in this molecule and molar mass of this molecule. Here you can see 2 nitrogen atoms are present. One nitrogen atom mass is 14, means in this compound 28 nitrogen mass is given. You need to write a relation between this compound NH4 to SO4 ammonium sulfate and nitrogen. In this molecule, you know 28 gram of nitrogen is present. You need to calculate the molar mass of this molecule also. 28 plus 8 because 8 hydrogen atoms are here, plus 32 which is the mass of sulfur, plus 64 which is the mass of 4 oxygen atoms, means 132. 132 gram ammonium sulfate contains 28 grams of nitrogen. So according to the question, if we are having 100 grams of ammonium sulfate, how many grams of nitrogen we will obtain? Here you will use unitary method or cross multiplication for calculation. 128 divided by 132 multiply by 100, so you will get the answer. (28 divided by 132 multiply by 100), so your answer is 21.2121, means option D. This is the correct answer. It is most closest answer. Number 6, if 100 molecules of acetic acid are ionized into acetate and hydronium ions out of 1000 molecules, means you have taken 1000 molecules, and from 1000 molecules you got 100 molecules which are ionizing, means 100 molecules are converting into ions, then means you will get 100 ions. Out of 1000 only 100 molecules ionizes. Then the number of ions produced by the dissociation of 100 moles of acetic acid, so here also you will do cross multiplication, but here 100 moles are given. First you need to convert these moles into number of ions by using the formula number of moles multiplied by Avogadro's number. So these are 100 moles multiplied by 6.02, so 602 exponent 23 are number of molecules. So here you will do unitary method, 100 divided by 1000 multiply by 602 exponent 23. So 60.2 exponent 23 is the answer, which is equals to 6.02 exponent 24. So option B is the correct answer. Now from number 7, chapter atomic structure, MCQs are starting. The magnetic quantum number value of 3D orbital is, for 3D orbital, for D, value of L, azimuthal quantum number is 2, and magnetic quantum number is actually starting from -2 till +2, all values including from -2 till +2. So option C is the correct answer. Number 8, in a discharge tube, the positive rays are produced when high-speed electrons strike the anode with large atomic mass. Positive rays. Glass wall opposite to the cathode, molecule of gas enclosed in the tube, radioactive polonium source directed by beryllium target. So here you can see anode with large atomic number will produce X-rays, not positive rays. Glass wall opposite to the cathode will not produce X-rays. X-rays are produced by gas molecules present whenever fast moving cathode rays will strike or fast moving electrons will strike the gas molecules. The positive rays will generate from here. So option C is the answer. Number 9, it is impossible to determine the exact position and the momentum of moving electron around the nucleus of an atom simultaneously. This statement represents Heisenberg uncertainty principle. Option D is the answer. Number 10, Henry Moseley did a systematic study of X-rays in the year 1913. According to his study, X-rays of shorter wavelength can be generated by option A, using an electrode of high atomic number. This is the answer. By using heavy metals or elements with high atomic number as anode will generate X-rays. Option 11, de Broglie wavelength of particle cannot be calculated by. So here option D is the answer. From this value, wavelength cannot be calculated because V will represent momentum, or V is the speed, M is the mass, but Q is the charge. Charge is also involved. This is the equation of de Broglie wavelength, but you can calculate it by using these equations also. Number 12, the correct representation of 3dz square atomic orbital is option B. The shape of dz square orbital is different from other d orbitals, and this one is the shape. Number 13, which of the following orbitals of oxygen hybridize to form 4 sp3 hybrid orbitals in water molecule? The electronic configuration of oxygen is 1s2 2s2 2p4, 1s2 2s2 2p4. In P there are 3 orbitals, px, py, pz. In S there is only one orbital. So these 4 orbitals are involved in hybridization, which is sp3. 1 2s and 3 2p orbitals. 2s and 2p orbitals are involved. So option A is the answer. Number 14, the molecule that shows zero net dipole moment is. The molecule should have symmetrical structure without any lone pair. It will show zero net dipole moment. A is the structure of water where there are 2 lone pair present. In central atom there shouldn't be any lone pair, so option B is the correct answer. Here both the dipole moment values of both the bonds will cancel out each other. Here lone pair is also present, and this is asymmetrical structure. All the remaining structures are polar in nature. They will not have net dipole moment 0. Only carbon dioxide will be having. Number 15. Given are the pair of orbitals showing overlap. The overlap that will result in a sigma 3p molecular orbital is sigma bond is formed by head-on overlapping. If you will see, this overlapping is head-on overlapping. This is not the head-on overlapping, only this orbital's head will strike, but this orbital side will strike, and this is sidewise overlapping. It will produce pi bond. So sigma bond here is produced in one only. Option A is the correct answer. Number 16. All of the following reasons are true about the directional nature of covalent bond except that the A shared electron are strongly pulled by the electronegative atom. This is correct. B bonded atoms prefer specific orientation in space. This is also correct. Number of anions surrounding cations is limited. There are no anions and cations present in covalent bond, so this is not related to covalent bond. Possible orbital overlap are few in number. This is also correct because orbital overlapping takes place in covalent bond formation. Number 17. The molecular geometry of ammonia according to valence shell electron pair repulsion is, this is the geometry of ammonia, where there are 3 bonds with hydrogen, and these 3 bonds will bend due to the presence of one lone pair. So this shape is like this. This is known as trigonal pyramidal. Option D, because a shape like pyramid is made which is having 3 corners, therefore trigonal pyramidal is called. Number 18. Given is the molecular orbital diagram of Be2 plus ion showing the molecular orbitals of the valence shell only. According to the given diagram, the bond order of Be2 plus is. For calculating bond order, you need to subtract anti-bonding electrons from bonding electrons and divide it by 2. Bond order formula according to molecular orbital theory is this: electrons present in bonding molecular orbital, BMO bonding molecular orbital in valence shell, minus electrons present in anti-bonding molecular orbital of valence shell divided by 2. So these are bonding molecular orbital, these are anti-bonding molecular orbital. There are no electrons present here in p orbitals. So bonding molecular orbital value is 2. 2 minus 1 divided by 2. Answer will be 0.5. 2 minus 1 means 1. 1 divided by 2, half, means 0.5. So option A is the correct answer. Number 19. Water boils at low temperature when there is low external pressure. In mountainous areas where altitude is high, air pressure or external pressure will decrease down, due to which boiling point of water will also decrease down. Number 20. At boiling point of pure liquid, until the entire liquid is converted into gas, the temperature of the system will remain constant. There will be no change in temperature during any physical change. Either it is boiling, melting, or evaporation, temperature will remain constant, because all of the heat will utilized in breaking of bonds rather than increasing temperature. Number 21. The option that is correct about the number of hydrogen bonds and the amount of energy required by a highly volatile liquid. Highly volatile liquid can convert into gas at room temperature. because there is very less number of hydrogen bond. Their intermolecular forces are very weak. So from A or B option, A or B, there is correct answer present. And here amount of energy that is required by highly volatile liquids. So here, because intermolecular forces are very weak, minimum amount of energy is required. So option A is the correct answer for question number 21. Question number 22, the electronic display device, the layer in electronic display device, the layer which is sandwiched between two sheets of polarized glass is composed of liquid crystal. This is the application of liquid crystals. Number 23, anisotropy is the property of crystalline solid in which few crystals show repetition of angle on 360 degrees centigrade. No, anisotropy is the property where crystals show different properties in different direction. Some crystals show variation in physical properties with direction. This is the correct answer for anisotropy. Two different substances exist in the same crystalline form. This is the definition of isomorphism. A compound exists in more than one crystalline form. This is the definition of polymorphism. So option B is the correct answer. Number 24, in the given table, the type of solid that correctly matches with its property. Ionic solid, good conductor of heat and electricity but in molten state. Covalent solids, malleable and ductile, no, they are very hard. Metallic solids, low melting and boiling point, no, they are having very high melting and boiling point. Molecular solids, soft and easily compressible. This is the correct answer because molecular solids like iodine are having least intermolecular forces, weakest intermolecular forces, therefore they are soft. Number 25. Given table shows two different phenomena, 1 and 2, in which crystal lattice exists. Crystal lattice of an ionic solid exists in two crystalline forms, rhombohedral and orthorhombic. Crystal lattice of an element exists in two crystalline form, cubic and hexagonal. The options that correctly identifies these phenomena is, this is related to polymorphism. As I have told you, one compound exists in different allotropic forms. So this is known as polymorphism. But here one element exists in different form. This is the phenomena of allotropy. So option D is the correct answer. Allotropes are the form of one element. These forms can be crystalline as well as amorphous. Number 26. The given crystal lattice is defined as, this one is hexagonal. How will you recognize? Because there are 6 corners. So this is hexagonal crystal system. Number 27. The dissociation of a weak acid hydrogen sulfide in water can be suppressed by the addition of. Hydrogen sulfide is weak acid. If you will add any common ion in it, its dissociation will suppress. NaCl is not having any common ion as hydrogen and sulfur are present in H2S. Hydrogen chloride is strong electrolyte, strong acid, and it is having one common ion also, and remaining compounds are not having common ion. Number 28. The condition that only affects the rate of reaction without disturbing the direction of reversible reaction is catalyst. Catalyst increases rate of reaction only. Number 29. The equilibrium constant value for the given reaction is this, that is very small value. Which of the following option is correct for the given reaction? When Kc value is very small, means a small product will form. Kc is directly proportional to product and inversely proportional to reactant, means we are having very small product and maximum reactant. Reactant maximum is present here, means reactants are very stable. You need to tell the stability of reactants also. They are not converting into product, therefore Kc value is very small. So from B or C, anyone can be answered. From Kc value, you can see Kc value is very small, so option B is the correct answer. Number 30. X is the property of a substance that shows its dissolution in a solvent and dependency on temperature, pressure and pH. Based on the given statement, the property X is defined as dissolution in solvent. It is actually solubility. Option D is the answer. And depends on temperature, pressure and pH value also. Therefore solubility is the answer, not solubility product, because solubility product is on equilibrium condition, and it is actually equilibrium constant value of partially soluble salts, and equilibrium constant values depends on temperature only, not pressure, not initial concentration, not pH, etc. So solubility is dependent on all three things. Therefore solubility is the answer. Number 31. A unit of equilibrium constant for the given reaction is 2 moles on product side, 1 mole on reactant side. So product upon reactant is Kc expression. There are two products, so both are having mole per dm cube unit. Concentrations are having mole per dm cube unit. So square I have written for two products. Reactant is only one, so I'll not put any square over here. This square will be cancelled out by this whole value. So mole per dm cube will be remaining. Option A is the correct answer. Number 32. Consider the given esterification reaction between acetic acid and ethanol, for which the value of Kc at 25 degrees centigrade is 4. To check the progress of this reaction, a sample from the reaction mixture is drawn and the value of Kc is calculated 2.5, which is less than constant value Kc. Now the calculated value of Kc depicts that the reaction. If this calculated value is less than your constant value, means reaction is moving in forward direction. It has not achieved equilibrium. To attain equilibrium, to achieve equilibrium, it has to move in forward direction. So option C is the answer. Will proceed in the forward direction to attain equilibrium. If this calculated Kc will become equal to this constant Kc, means reaction is at equilibrium, and if this calculated Kc is greater than this constant Kc, means reaction is moving in backward direction to attain equilibrium. So in this condition, option C is the correct answer. Number 33. In the given reaction, the reactant H2O can be classified as: H2O is having oxygen as central atom, which is from 6A group, and it is having lone pair also. So it will donate lone pair in any reaction and will act like Lewis base. Chromium is cation. Cations are electron deficient species. They will gain electron pair in any reaction. So this one is acid. H2O is acting as base in this reaction. Number 34. When methanol react with water, it acts as a Bronston-Lowry acid with the equilibrium position lying very far to the left. Which of the following options correctly depicts the strength of acid and its conjugate base in the given reaction? This is an acid and this is the conjugate base. Equilibrium position lying very far from the left. This one is weak acid. So either option A and option C are correct. Conjugate base will be stronger because weak acids are having a strong conjugate base and strong acids are having weak conjugate base. This is proved by this relationship between acid and base. Ka, ionization constant of any acid, multiplied by Kb, ionization constant of its conjugate base, is equals to Kw, which is a constant value, 1 exponent minus 14. So if we are having weak acid, its conjugate base will be strong, and if we are having strong acid, its conjugate base will be weak always. Number 35. The pH of a sample containing this much molar solution of potassium hydroxide is. You need to calculate the pH. Molarity of the solution of potassium hydroxide is given. From molarity of a base, you can easily calculate pOH value. By subtracting pOH value from 14, you will get pH value. So we have formula of pOH because in case of bases we are having hydroxyl ion concentration only. So from hydroxyl ion concentration we need to first calculate pOH value. Hydroxyl ion concentration is same as the concentration of base because this is the base having one hydroxyl ion. If we are having this much moles of base, it will produce this much moles of hydroxide ions. So we have to calculate log of this value 0.0125. Log value is in minus, so means it is in plus. Minus minus will become plus 1.903. You need to subtract this value from 14 to obtain pH value. 14 minus 1.903, your answer is 13.09. because I have not taken the complete value 3 decimal places, therefore there is no option written here. So let's take the complete value 0.0125 log, it is 0.0125 log 1.9030899. So let's take the complete value 8 till 89986. So 14 minus 1.9030899. Oh, 12.1 or 12.09. So option C is the correct answer. So try to take the complete value. If you are using scientific calculator, there will be a key of answer. You can press that key simply to get the answer. So option C is the answer. Number 36. Which of the following statements is true about the buffer solution? Their pH alters on dilution. No, the pH of buffer solution is constant. Buffer solution resists to change the pH. They have a specific constant pH value. Yes, this is the correct answer because their pH values are constant. Option C, why it is wrong? They show a change in pH on addition of acid. In case of buffer solution, either we use a small amount of acid or base, their pH will remain constant. Their pH will not change. Their pH varies upon standing for a long period of time. No, they resist to change in pH in any condition. So option B is the correct answer. Number 37. The pH of a buffer solution prepared by using this much molarity of this salt and this much molarity of this acid in a solution. You need to find out pH where concentration of salt and concentration of acid is given, and in note Ka of acid is also given. You have to use Henderson-Hasselbalch equation for calculating pH of any buffer, which is pKa plus log concentration of salt divided by concentration of acid. Here concentration of both are given, salt and acid. So let's calculate. Salt's concentration is 0.04 divided by acid's concentration 0.02. Let's take the log of this value 0.03010. For you need to calculate log of this value also, minus log of Ka. No, this will not calculate in this calculator. 6.4 exponent minus 5 log plus 4.19382. This is the pKa value. P means minus log of Ka. So I have calculated minus log of Ka. And here we will calculate concentration of salt, that is 0.04 divided by concentration of acid 0.02. Then let's take the log of this. 0.04 divided by 0.02 log, it is 0.3010. Add this value in it, and the value is 4.19382. Your answer is 4.49, that is option C. By using this equation, you can calculate pH of any buffer solution. In case of acidic buffer, in case of basic buffer, this equation will change with POH and this will change with PKB, because there you will use base. Question number 38. The molarity of 0.025 decimeter cube solution containing 10.35 grams of K2CO3 is. Volume is given already in decimeter cube, so you do not need to convert it. Mass is given, you just have to calculate molar mass of K2CO3, that is 2 potassium 39 plus 39, 1 carbon plus 12 plus 3 oxygen atoms 16, 16, 16. So 138 is the molar mass. Formula is mass upon molar mass 10.535 divided by molar mass into volume in decimeter cube. Molar mass is 138 multiply by 0.25. So here you can simply calculate the answer. 10.35 divided by 138 divided by 0.25. Answer is 0.30, option B. So in question number 38, option B is the correct answer. Now question number 39. Consider the given cooker as a system. If no work is done by the system and internal energy is 0, then the energy change delta E of the system means there is no change in energy in this system. No work is done. There is no way of transfer of energy from this system. No work, no internal energy change, means only heat is the form to transfer energy from this system. 15 kilojoules heat is entered to the system, but 3 kilojoules heat is left in the system. Now energy change will depend on Q only, change in heat only. 15 is added and this system has absorbed some heat and it has released 3. So what you need to do, just subtract final heat from initial heat, means 15 minus 3. Your answer is 12 plus 12, that is option A, because both the values were in plus, therefore option A is the answer. Number 40. In a calorimeter, 13.3 moles of water are used to measure the heat of combustion of 0.30 gram of sugar. The specific heat capacity of water is 4.2 and the rise in temperature is 5 Kelvin. Now mass is given, S value, specific heat capacity value is given, delta T is given. You need to calculate delta H. Delta H formula is the amount of heat evolved during the combustion of 1 mole of sugar. Delta H formula is amount of heat divided by number of moles, and amount of heat can be calculated by using this formula, M S delta T. All three values are given. So let's calculate, but this will give you amount of heat in joules, because specific heat capacity value is given in joules. So you need to convert in kilojoules also, because all the values in answer are in kilojoules. Mass is 0.303 multiply by S, that is 4.2, multiply by delta T, that is 5. Your answer is 6.363. You will divide it by 1000, it will convert it into kilojoules. Let's calculate it again. 0.303 multiply by 4.2 multiply by 5 divided by 1000. Now you need to divide it by number of moles. Here I made a mistake in calculation of formula. Here mass of water is needed, because sugar is dissolved in water. Water is used to measure the heat of combustion. So actually mass of water is representing the overall mass. So here from 13.3 moles we need to calculate mass of water. Therefore molar masses of both are given. So here mass you need to calculate 13.3 multiply by molar mass of water, moles multiply by molar mass, you will get mass of water. So this mass you need to calculate use in this formula. So multiply by 4.2 multiply by 5. Answer is 5027.4, but this is the value of Q. You need to convert it into kilojoules. Convert it into kilojoules by dividing by 1000. Now this is the value of Q. You need to divide it by number of moles. Here number of moles we will take this one, because sugar's amount of combustion, heat evolved during the combustion of sugar is need to be find out, not water. So number of moles of sugar are required here. 0.303 mass is given. 0.303 mass divided by molar mass of sugar 342.3, you will get this much molar this much moles of sugar. You need to divide your kilojoules value with this number of moles, 8.8518 exponent minus 4. So your answer was 5.0274 divided by 8.819 exponent minus 4. Yes, this is the value. I think I have written the wrong value. 303 divided by 342.3, 8.85188. Let's divide it. So your answer is 679.4, which is very close to 5686. This is the correct answer. So here you will use the overall mass, which is used in the calorimeter, and then you will divide the number of moles of substance which has to be find out. Here number of moles of sugar will be used. Therefore molar masses of both are given. So next question is number 41. Given are the standard enthalpy changes for the series of reactions occurring in the formation of lithium fluoride, LiF. The lattice energy of lithium fluoride is. This is the question related to Born-Haber cycle. You need to add these values: sublimation energy, ionization energy, bond energy, electron affinity energy. Add these values and subtract it from this enthalpy of formation. So your answer will be option A. Let's do it. 155.2 plus 520 plus 75.3 minus 328. 422.5. 422.5. 422.5 minus 422.5. You need to subtract all these values from this value. So 155.2 plus 520 plus 75.3 minus 328 plus answer is A. Why I have added? Because this value was written in negative and this was the large value than for 422.5. So you need to add the values and write unit of the larger one. Okay, now question number 42. Below are the thermochemical series of the oxidation of carbon and carbon monoxide with the associated enthalpy change. Based on the given information, the enthalpy of combustion for carbon forming carbon dioxide will be. Now what you need to do, you have to either add or subtract these two equations so that you can get this resultant equation. If you will add both the equations, you will get this equation, so you need to add these values also. 109 plus 284.5, 393.5, and my answer is in minus, so option D is the correct answer. Number 43. Given are the two half cell reactions and their standard reduction potential, the overall cell potential of the electrochemical cell will be. This is reduction potential and this one is also reduction potential. If you will add both the values, you will get the answer. This one, you need to just add both the values. But in case of oxidation potential, in case of anode, you will put oxidation potential because at anode oxidation takes place, and this one is small value of reduction potential, means nickel will go on oxidation, not reduction. This is the formula for calculating cell potential. E cell is equals to reduction potential which will take place at cathode plus oxidation potential which will take place at anode. So here oxidation potential value of this species nickel will be plus 0.25. If you are putting here oxidation potential value, then plus formula you will use. If you will put in reduction potential value, here you will use minus formula. So therefore you have added these two values. So answer is option A. Number 44. Which of the following statement is false about the fuel cell? It uses water as a source of to produce. No, it is not using water, it is producing water. So option A is the wrong for fuel cell. Number 45. An example of oxidation half reaction. Oxidation is loss of electron. So here in oxidation, here you can see from plus 2 oxidation state is changing to plus 3, means this equation is showing loss of electron, or oxidation state is increasing, this is also oxidation. Here you can see gain of electron, oxidation state is decreasing, so this is reduction. Here also from 0 to minus 1 it is decreasing, and here also 0 to minus 3 it is decreasing. All three processes are reduction process. This first one only is the oxidation process. Number 46. A current of 5 ampere is passed for 2 minutes during the electrolysis. The amount of charge transferred is, charge is current multiply by time. So from this formula your answer will be time should be in second, but here time in minutes are given, so you need to convert it into second. That is 120. 120 multiplied by 5, 600 is the answer. Okay, number 47. Which of the following is not a redox reaction? Where there is no change in oxidation number, that equation is not the redox reaction. Here sulfur's oxidation state is changing from -2 to +6, means this is +6, means this is redox reaction. Here also sulfur's oxidation state is changing. Option C is the answer, where magnesium oxidation state is same, +2, hydroxyl oxidation state, hydrogen oxidation state, even sulfur oxidation states are same, +6 and +6. Here also it is changing from +4 to +6. So option C is the correct answer. Number 48. Consider the given reaction. The substance that acts as oxidizing agent in the given reaction is. Here you need to find out oxidation states of every species. Oxygen is in free state, so it is 0. Fluorine -1, +1. Here oxygen -2, +2. And here fluorine is -2 and oxygen is +2. So oxygen oxidation state is changing from +2 to 0, means it is decreasing. This species is being reduced in the reaction, so it is acting as oxidizing agent. OF2 is the correct answer. Number 49. The oxidation number of iron in Fe2O3. Iron oxygen -2, 3 oxygen atoms are present, means -6. It should be +6 for 2 iron, but for 1 iron it is +3. Option C. Number 50. The value of W, V, W, X, Y and Z correctly balance the given equations are. You need to balance the equation. Here option D is the answer, because V is written here which represent phosphorus and Y is written here which represent phosphorus. These numbers should be same, V and Y. 3, 3 you can see. And here W is the number which is showing nitrogen and Z is the number which is showing nitrogen here. So W and Z should be same, W, Z 5, 5. So option D is the correct answer. This was all about theory. Now ATP paper is starting. Question number 51. A student carries out a gravimetric analysis of 20 ml solution of BaCl2 to estimate the amount of barium ion present in it. The molecular weight of barium is salt formed is 253.4 and that of barium ion is 137.4. The observation concluded during the experiment is. From this observation you can easily calculate the mass of barium ion by subtracting the mass of filter paper. 1.8 minus 0.9 means mass is 0.9 of barium ion. With reference to the given observation, the amount of barium ion that will be present in 1000 ml of the solution is. Now see, here 253.4 gram of salt will give 137.4 grams of barium ion. So 0.9 will give how much barium ion in 20 ml. So it will be 137.4 divided by 253.4 multiplied by 0.9, that is 0.48800. 0.488. These are in 20. You need to calculate in 1000. Divided by 20, multiply by 1000. So your answer is 24. Option C. Option C is the correct answer. Number 52. After completing separation of mixture through paper chromatography, its component can be identified by comparing the retention factor of spot or RF values. Number 53. The effect of common ion in a solution is that it suppresses the dissociation of partially soluble salt. Decrease the number of ions in the solution. No, it is for partially soluble salts only. Shifts the equilibrium towards right. It shifts the equilibrium towards left. Increase the rate of reaction. It increases the rate of backward reaction only and decrease the rate of forward reaction. So only option A is the correct answer. Number 54. The addition of one compound to a solution to another compound having a common ion causes these ions to precipitate that have low solubility product. Option B is the answer, because low solubility product compound will be having less number of ions, so its dissociation will suppress very easily. High solubility product values are completely soluble substances. Number 55. A soap solution was prepared by using sample of 8 gram laundry soap. The calculated result of the titration between this soap solution and HCl shown 1.4 gram of free NaOH is overall utilized. The percentage of free NaOH used in this titration is 1.4 was calculated and total you have taken 8. Percentage formula you will use, multiply by 100. So here 1.4 divided by 8 multiply by 100. Option C is the answer, 17.5. Number 56. The value of X in oxalic acid formula is given is 2. Then the amount of this compound in 1000 cm³ of 1 m solution is. If the value is 2, the molar mass is 126. 1 m solution molarity is given, molar mass is given, amount is required. 126 multiplied by 1000 cm³ means 1 decimeter cube. So here mass is option D, 126. Now question number 57. Usma had 60 gram impure sample of sodium carbonate. She made a solution using 9 gram of this sample in 250 cm³ volumetric flask. A titration was performed against the standard solution of HCl by taking 10 cm³ of solution formed and using methyl orange as indicator. She determined that the solution contained 5.3 gram of pure sodium carbonate. Based on the result, the amount of pure sodium carbonate in an entire sample is 5.3 is present in 250 ml, where she has taken 9 gram sample. So from 9 gram she obtained 5.3 was present. So from 60 gram how much can be obtained? 9 grams give 5.3. So 60 will give how much? Let's calculate. 35.3. Option C is the answer. You do not need to use any titration formula here. You have to just use the ratio because they have already calculated the amount in the titrated solution. You do not need to calculate it. Number 58. A student has to determine the molarity of sulfuric acid through a volumetric analysis. 2 different bases and 2 different indicators are mentioned in the table. The correct combination of base and indicator that she could use for performing the experiment is NaOH and methyl orange. Sulfuric acid and NaOH both are strong acids, so methyl orange cannot be used. Sulfuric acid is a strong acid, so we can use any base with it. Sodium carbonate is weak base. From weak base methyl orange can be used, so this can be correct answer, correct option. 3. NaOH and phenolphthalein with the strong base phenolphthalein is used. Sodium carbonate, phenolphthalein, this is also wrong. So 2 and 3, option D is the answer. Next, use the given information to answer question 59 and 60. Zayan prepared a solution of oxalic acid at room temperature. He filtered and took 5 cm³ of this solution and prepared 100 cm³ solution in a volumetric flask. Finally, he prepared out 10 cm³ of 0.1 ml standard NaOH solution and titrated it against 8 cm³ of oxalic acid. He calculated the concentration of oxalic acid in 8 cm³. Here you need to use the formula, that is M1V1 upon N1. NaOH will be used in this balanced equation 2 moles, because in oxalic acid 2 moles H2C2O4, 2 hydrogen atoms will replace by 2 sodium atoms. So sodium hydroxide molarity is 0.1 multiplied by volume, that is 10, divided by number of moles, that is 2, is equals to oxalic acid molarity. You need to find out, volume is 8 divided by 1. So here you need to calculate this. .625 is the answer, is the molarity of diluted solution. The solubility of the first solution that Zayan has prepared at room temperature is, now see, first he has prepared a solution at room temperature. From this solution he took 5 cm³ in another volumetric flask with 100 ml volume. So we have calculated the molarity of this solution, because this solution was used in titration. So molarity of this solution is 0.0625. Here you are going to use dilution formula, which was present in 100 cm³. Molarity is 0.0625, present in 100 cm³. You have to calculate the molarity of first solution first, then convert it into solubility, and volume taken from first solution was 5. So multiply by 100 divided by 5. This is the molarity of first solution, 1.25. Now convert this molarity into mass per dm³. It is already in dm³. You have to just divide it by multiply it by mass, because molarity represents, molarity formula is moles per unit volume. Moles are mass over molar mass. If you need to calculate mass, multiply molarity with molar mass. So molarity is 1.25. Molar mass of which solution was this? Oxalic acid. Oxalic acid molar mass is 126. So 15, your answer is 157.5. You need to convert it into 1000. No, you need to divide it by she took 5 cm³ of this solution and prepared this much. Let's calculate it again. Okay, divided by 1000, multiply by 100, because this was the molarity in 1000. You need to calculate it in 100 ml also. This molarity you need to convert into 100 ml, because the solution was prepared in 100 ml. So option D is the correct answer. Number 61. Consider the given acid and base pair. A acid base pair which on neutralized generate 13.7 kilocalorie per mole. This value of heat is generated by the neutralization of strong acid and base. So here 1 is showing strong acid and base, in 2 this one is weak base, this one is weak base, 4 is showing strong acid and base. So 1 and 4 is the correct answer, that is option B. Number 62. During the standardization of KMNO4, the standard solution of oxalic acid with dilute sulfuric acid is heated at 60 degrees centigrade because this temperature increase the visibility of solution, no. Removes the impurity of oxalic acid, no. Speed up the production of Mn plus 2 ion. This is the correct answer. D is also wrong. Requires high consumption of KMNO4, only temperature is increased to convert the ions. 63. To determine the exact concentration of KMNO4 solution, it needs to be titrated against standard solution because it reacts in acidic medium, releases nascent hydrogen, changes its concentration because secondary standard solutions concentrations are not fixed, therefore it has to be titrated. Number 64. Which of the following statement is correct about redox titration? It involves proton transfer, no. It is done in acid base titration. It typically requires an indicator, no. KMNO4 acts itself as indicator. It is carried out with transition element, yes, because transition elements are having property to change its color and they are having variable oxidation state. It always produce water as a byproduct, no. This is not correct for every reaction. The given picture illustrates 3 ways of observing burette reading for colorless solution. The correct way to read the burette reading is eye level, that is 2 only, option B. So this is the end of ATP paper. Also, this was all about 2021 paper. Hopefully you understood everything. If you need to ask anything, you can ask in comments. Okay, thank you. Allah Hafiz.